Hello again. Welcome back to Star Review Book, live with Mr. Jones. Today we are looking at reporting category 3, which is more linear stuff, but it's more of the writing linear equations and whatnot. And it's probably the most extensive in this book. There's a lot to go over. I'm going to try to go as fast and get as much information in as possible. Again, if you need this, if you want to watch this again, it'll be available on Canvas and on YouTube. Subscribe and like and leave comments. Just kidding. All right, so the first thing, when we write a linear equation, we know there's two things we need: a slope and a y-intercept, or 2 points that we can find the slope from and use one of the points. We just need two pieces of information in order to get these two things, and then we can write our equation. All right, y equals mx plus b, which is slope-intercept form. And then this, to get it into standard form, remember we just moved the x to the other side. You have negative 2x plus y equals 3, and then we flip the sign because we don't want to lead with a negative. Alright, if it is already in standard form, we are going to, let me lock this real quick because it is going all over the place. We have to solve for y, which is an easy process, so it's just getting y by itself. I'll do number 2 here since we have negatives here, so we're going to add 7x to both sides. And you're going to have to write smaller here because there's limited space. That gives us negative 6y equals negative 8 plus 7x, and then we have to divide by negative 6. It gives us y equals, I'm going to go ahead and reduce this fraction and make it positive because it's a negative over negative, 4 over 3 plus, or minus rather, because we have a positive over a negative, minus 7 over 6x. Right. So again, writing an equation, you need the slope and a point, or you need a equation in standard form. Or you can be given a point and a slope, in which we use the point-slope formula. And this is on your formula sheet that you will have provided. Sorry. All of these linear forms are on your formula sheet. So we got standard form, slope, intercept, point, slope, and even how to find the slope. So those little posters I have around the room, a lot of that information is provided to you already. So if you are given just a point and a slope, it's easiest just to use point-slope form. You plug in your slope, plug in your point, and y minus y1 equals m times x minus x1, and just simplify it. All right, and it's really effective and useful when we are finding perpendicular and parallel lines. All right, one, if you're given the equation of a line, these are both in slope-intercept form. Sometimes they'll give you it in standard form, and you have to get it to slope-intercept form, and you would just do the same thing we did up here. But this, we already have it in slope-intercept form, so we know what our slope is. I'm going to do what is usually the harder one, and start with the perpendicular one, because perpendicular lines have, you change the sign and you get the reciprocal. So our slope of this line is 2 over 3. And it's positive. So our new slope is going to be negative 3 over 2. All right, and they give us the point negative 6, 5. So we know what x and y are, and they are negative 6 and 5. So you plug all that information into point-slope form. We have y minus our y value, 5, equals our slope times x minus our x value. So this would be minus negative 6, which would then be plus 6, because we have minus and negative. And then we just simplify this, so we distribute that slope, so you get negative 3/2 x minus, because we got negative times a positive, that would be 18 over 2, which that fraction will simplify to 9. And then we add 5. So your equation, -3/2 x minus 4. And just for your edification, if you are to do this later, the answer to this one is C. The only difference from here is that the slopes are the same since they are parallel lines. They're the exact same thing, but the slope is going to be the exact same. Horizontal lines go through the y-axis, so they are going to be y equals whatever the y value is of any point on that line. So for instance, if I have, they tell me that I have this point and it's say 3, 2. There's a horizontal line going through it. My equation is going to be y equals 2. That's the y value. For a vertical line, say if I had that same graph, same point, vertical line going through that point. Oh, you cannot see that. So you got this point, vertical line going through it. It's going to be x equals the x value of that point. Slope is 0 on horizontal. You can walk on a horizontal line, but it's not going up or down. You cannot walk on a vertical line, so it's undefined. When graphing inequalities, it's the same thing as before. You solve for y, and it's the only thing you have to remember. When you do put it in the calculator, less than is the below the line, greater than is above the line. We've had a little practice on that, so you should know that. When you have systems, you're either going to have one solution, no solution, or an infinitely many solutions. That's when the lines lay on top of each other. Lines never cross, they're parallel. Lines intersect at one place, so there's one solution. And to solve a system, there's 3 ways you can solve it. Both this one, if they're already in y equals, or if you want to get them in y equals, you can put it in the calculator. So let's look at that really quickly. Where is my calculator? Where is it? It's one of you ragamuffins. Start my calculator. Alright, so you go here. My battery's low, watch it die. Oh. Let me pause real quick. And it did not pause. One moment. Alright, so I found my calculator. So you put the first equation to y1, second equation into y2. Then you graph them, make sure they show up on the page. Boom. So our solution is there. Second trace, we're finding where they intersect. First line, enter. Second line, where's my cursor? Oh, it is on there. So we want to make sure it is on the second line. And our intersection, our solution, x equals 1, y equals -3. So it is the point 1, -3. So you can do the same thing. Another method you can use is elimination. I'll do that on number 3. So you want to get a term to match so you can cancel it out. So we can multiply this by 5 so we can get these 5s to cancel out. This one's already negative, this one's positive, so let's just go ahead and make it the same. So you're left with -5x minus 5y equals -20. You got -10x plus 5y equals 35. Let's get -15x, so we're adding these two, those go away, equals 15 divided by -15, x equals -1. So you take this -1 and plug it into either one of these equations. I'll plug it in the first one. So I got -5 times -1 minus 5y equals negative 20. Run out of space. So you get 5 minus 5y equals negative 20. Minus 5, negative 5y equals negative 25. So y is going to equal 5. So negative 1, 5. Alright, when you're looking at a table, you just find where they have the same y value. Sometimes you'll have a table that puts both of them together, like so. And so the same table will be x, y1, y2. You're just finding where the y's are the same. Alright, the hardest part with application problems is just coming up with the equation. So look for totals and you look for linear equations. We know we seem to have find the equation of the linear or in slope-intercept form pretty easy, but most application problems are going to be in standard form. But the first thing is to define your variables, and then just plug everything in. So let's do this one. The admission fee at a small fair is $150 for children and $4 for adults on a certain day. 2,200 people enter, and 50-50 is collected. Alright, so we could say X is number of children, and Y is the number of adults. We do know there were 2,200 people, so 2,200 equals X plus Y. They made this much, so it was this much per person for each of those different type of people. So 50-50 equals 150 for children and $4 for adults. And then you would just solve that. Alright. And the last thing is direct variation, just setting up a proportion. Put the same in the same places. This could have been 100 over 4 equals 5 over x. Or however, they just need to be, the same parts need to be in the same places. So if Heather's weekly pay is directly proportional, she gets paid $174 for 24 hours of work. Find the amount for 40 hours. So 174 over 24. We're trying to find that amount for 40 hours. So then you cross multiply. So 40 times 174 and divide by 24, and X equals $290 for 40 hours. Wow. Anyhow, so that is reporting category 3. It should be about to rotate stations. So I tried to make it as short as possible, but there is a lot of information to cover in this one. So I'll see y'all. Well, I'm in here now, so I will look at you and watch this.